Hello. So this is a video on basic index form. And the first question is write in index form 8 multiplied by 8 multiply 8 multiplied by 8 multiplied by 8 multiplied by 8 multiplied by 8. So our simple way of writing this, which you may have learnt in previous years, is 8 to the power of 7, because 8 is multiplied by itself 7 times. Notice this is not 8 times 7, 8 multiplied by 7. This is 8 multiplied by 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 8. So it's 8 multiplied by itself 7 times. And it's very important to realise the difference between 8 times 7, which would be 8 add 8, 7 times, whereas this is 8 multiplied by 8. So here, write this in index form. Now notice there's a negative 4 here. So it's not positive 4, it's negative 4, and that's why I've put it in brackets. So my answer here would be negative 4, which would be inside the brackets, raised to the power of 3 or cubed. Okay, next one. Write as a product. What does product mean? Product's another word for multiplying. So my answer for this would be 5 multiplied by 5 multiplied by 5 multiplied by 5. Because 5 to the power of 4 is 5 multiplied by 5 multiplied by 5 multiplied by 5. Right, and the last example. So here you can see we're multiplying by 3 and by 7. Well, first of all, it is better to regroup these so that I have my multiplying 3's or my product of 3's together, and then I can do that for the 7's. Now, the rule I'm using here is the commutative law, because the order that I multiply doesn't matter. So if I do 2 multiplied by 7, I get 14. If I do 7 multiplied by 2, I still get 14. So the order that I write the numbers doesn't matter because of the commutative law, which works only for addition and multiplying. I can change the order and it not affect my answer. Notice I can only do that for adding and multiplying. So here this would be 3 to the power of 5 multiplied by 7 to the power of 3. So that's some basics to start with, and we've just learnt about what the importance of the power is and what it actually means. So now just moving this on a little bit to understand a little more about index form, I want us to look at some patterns, and what you'll notice here is I've written 4 cubed, which is 4 multiplied by 4 multiplied by 4, then 4 squared, which is 4 multiplied by 4. And what you should have noted is that if I go from here to here, it's actually the same as dividing by 4. So 4 to the power 1, I know what that is, that's 4. Well, again, to go from here to here, divided by 4. And you may be thinking, why am I doing this? Well, it's to help you understand what 4 to the power of 0 is. Well, 4 to the power of 0 is actually 1. And again, looking at that pattern, I would divide by 4. And 4, because 4 divided by 4 is 1. So then looking at these here I'm dividing by 5. So here I'm going to again divide by 5, but I know 5 to the power 1 is 5. So 5 to the power 0, what's the answer for this going to be? Can you work out? Let me just go back through it if you haven't quite realised what it might be. 4 to the power 1 is 4. I divide by 4, 4 to the 0 is 1. 5 to the power 1 is 5. I divide by 5. 5 to the power 0 is... yes, it's also 1. So what I want you to do is notice this. 4 to the power 0 is 1. 5 to the power 0 is 1. And actually, if I did this for all the numbers, you would find that anything to the power of 0 is 1. So anything to the power 0, so I'm going to say x to the power 0, it's 1. 1 million to the power 0, that's 1. 1/3 to the power 0, it is 1. And the other thing I want you to realise that anything to the power of 1, so x to the power 1 is x. 1 million to the power 1 is 1 million. And 1/3 to the power 1 is 1/3. And I would, in your book, write that down. So anything to the power of 0 is 1. And anything to the power of 1 is just itself. And in particular, something to the power of 0 has often come up as a GCSE question. And just for 1 mark, to check that students know that. So that might be of interest to you if you're doing GCSEs. This might be a 1 mark question for you, and an easy 1 mark question if you understand and know that anything to the power of 0 is 1.